Welcome to the class on X-ray crystallography. We will be discussing about the crystal systems in the today's class. Now, when you take a crystal which is nothing but a solid in 3 dimension, keep on dividing into a smaller unit. You end up in the smallest one, which is called the unit cell. In other words, the unit cells are the building block of the crystal. These unit cells are classified based on the symmetry in 3 dimension. It is nothing but a volume which is linear side, which is having a linear side, not a curved surface like a cone or circle. So, the unit cell can be defined based on the side and the angles between the sides. So, to define a volume, in 3 dimension, we need 3 sides. So, let us say this way. Now, I can say this is A, B and C, and the angle between the sides, say between A and B and C and C and A. Now, when you take these 3 sides like A, B, C, we write the respective Roman letter alpha, beta, gamma, Greek letter alpha, beta, gamma. Now, we can define this way. Angle between A and B, that is A and B, the missing respectively is gamma. So, that becomes gamma here. Now, between B and C, the missing is alpha. So, then this becomes alpha. Now, between A and C, the missing is beta. So, this angle becomes beta. So, easy to remember, no need to mark up. Now, having decided the dimensions, let us construct the volume. This is the origin. So, A, B and C, and this is alpha, this is beta, this is gamma. Now, we can see that C and alpha, A and C and gamma, A and alpha, B and beta are the corresponding. Now, when you define this, let us say A is not equal to B, not equal to C. Alpha is not equal to beta, not equal to gamma, not equal to 90. That means, the 3 sides A, B and C are not equal. I can put it not equal, not equal or not equal. So, that is what it means. Now, the angles alpha, beta, gamma, they are not equal to 90. Now, when you look into this, the axis A is not perpendicular to the BC plane. Same way, B is not perpendicular to AC plane. Same way C is not perpendicular to AB plane. Now to define the volume in this case, we need 6 independent parameters. This system is called the triclinic, or we can write here triclinic system has got 6 independent or variable parameters. In this case, in triclinic, the axis A not equal to B not equal to C and angle alpha not equal to beta not equal to gamma not equal to 90 does not give any symmetry. No symmetry is generated in the box, or there is nothing but the unit cell. So, this is the lowest symmetry. Now, when we climb up, let us say A is not equal to B, not equal to C, and alpha is equal to gamma is equal to 90, beta not equal to 90. In this case, the B axis becomes perpendicular to the AC plane. So, when we construct it, let us say this way. Now, this is my C, this is my A, this is the origin. Now, the B axis is perpendicular. B axis is perpendicular to the AC plane. So, now this becomes beta. So, when you take this case like the projection down the B axis, this is my beta, this is my C, this is my E. Now, this axis, that is the B axis perpendicular to AC plane. Now, we can imagine, let us try to complete it. When this is the perpendicular one, this is the B axis, that implies there can be a mirror. Perpendicular to the B axis or parallel to the AC plane. Further, in the case of monoclinic, when A is not equal to B not equal to C, the B axis is called the symmetry axis or unique axis. So, then what happens? You take the same projection, this is my C, this is my A, this is down B. Now, I can see at the midpoint, I can have a rotation symmetry. Now the rotation symbol is mentioned here. See, this means the rotation axis is perpendicular to the plane of the board. When we write this way, is parallel to the board in the x-axis, or when you put it this way, again is parallel to the board in the y-axis. So, in the case of monoclinic, there are two symmetries generated, that is, one, a twofold axis along the B axis. 2. A mirror perpendicular to the B axis, that is, the AC plane can act as a mirror plane. So, in that case, in monoclinic, when we write A not equal to B not equal to C, alpha is equal to gamma is equal to 90 and beta is not equal to 90, we need 3 plus 1, only 4 parameters. That is only 4 variables. Now, when we climb up, let us say A is not equal to B, not equal to C, alpha is equal to beta is equal to gamma is equal to 90. Now, this belongs to the system called orthorhombic. In this case, A axis perpendicular to BC plane, B axis perpendicular to AC plane, C axis perpendicular to AB plane. That is, all the 3 axes A, B, C are mutually perpendicular are orthogonal to each other. In the case of orthorhombic system, because of the three axes which are mutually perpendicular, it can generate 3 mirrors perpendicular to each other. that is AB plane perpendicular to AC plane and BC plane. BC plane perpendicular to AB plane and AC plane, or AC plane perpendicular to AB plane and BC plane. Further, the three axes are perpendicular, which can generate a twofold symmetry. In orthodynamic system, all the axes A, B and C are called symmetry axis. So, to define an orthodynamic system, we need only 6 variable only 3 variables A, B and C. No need to mention alpha, beta, gamma as they are 90 degrees. Then further if we climb up, A is not equal to B, not equal to equal to A, B, C. Now I make two axes equal, that is A and C, or A is equal to not equal to B, not equal to C. In that case, it can be rotated or relabeled, like A becomes B, that means call this as B, this becomes C. Or this can be A and this is B, then this becomes C. So these two are equal and this is not equal. So we can call it A is equal to B not equal to C, and written alpha is equal to beta is equal to gamma is equal to 90. This is nothing but a tetragonal system. Where there is a square base, this is my A and this is my A, and the perpendicular axis is C axis and this is 90. So this can be rewritten as A is equal to A not equal to C. So we need only 3 variable. No need for alpha, beta and gamma. In the tetragonal system, the C axis called the unique axis and the symmetry axis. Here the base is a square that is A is equal to A. So there can be a four-fold rotation. That is, at the midpoint there can be a 90-degree rotation. Further, let us consider A is not equal to, let us consider A is equal to B is equal to C and alpha is equal to beta is equal to gamma not equal to 90. In this case, the axes A, B, C are equal and the angles alpha, beta, gamma are equal, but nothing is equal to 90. Then this is called the trigonal system. Here, no axis is called the symmetry axis. We need only 1 and 1 and only 2 parameters to define. In the trigonal system, the body diagonal passing through the is acting as a rotation axis, that is a three-fold axis. Further, when we consider A is equal to B not equal to C, alpha is equal to beta is equal to 90, gamma is equal to 120. This is nothing but the hexagonal system. Now we can draw the projection like a 6-member ring. Next again, this is your A and this is your A, or say B, and this is the angle 120, that is gamma. So this is now A plane or AB plane is perpendicular to the C axis. In the hexagonal system, the C axis, the unique axis is the unique axis or symmetry axis along which a six-fold rotation can be operated. Further, when you consider A is equal to B not equal to A is equal to B is equal to C, and alpha is equal to beta is equal to gamma is equal to 90. Here this is nothing but a cubic system where the three sides are equal, so it is written as A and alpha beta gamma 90. So here A, B, C are indistinguishable. Now this is my A, this is my A, the perpendicular axis is also A. So that means you can construct a cube this is called the isometric. To define the cubic system, only one parameter, that is A, is needed. Now let us summarize. Triclinic, A not equal to B not equal to C, alpha not equal to beta not equal to gamma not equal to 90. So 6 variable. Monoclinic, A not equal to B not equal to C, alpha is equal to gamma is equal to 90, beta not equal to 90. So 1, 2, 3, 4 parameter. Orthorhombic, A not equal to B not equal to C, alpha is equal to beta is equal to gamma is equal to 90. So we need 1, 2, 3 variable. Tetragonal, A is equal to B not equal to C, alpha is equal to beta is equal to gamma is equal to 90. So we need only 1 and 2 variable. Trigonal, A is equal to B is equal to C, alpha is equal to beta is equal to gamma not equal to 90. We need only one variable and here one variable. So only two variable. And you go to hexagonal, again A is equal to B not equal to C, alpha is equal to gamma is equal to alpha is equal to beta is equal to 90. And gamma is not equal to 120. So we need only 1 and 2 variable. Then comes cubic. A is equal to B is equal to C, alpha is equal to beta is equal to gamma is equal to 90. So one variable. Now when you take these 7 systems 1, 2, 3, 4, 5, 6, 7, the lowest triclinic system, no symmetry is possible, but only inversion. In the case of monoclinic, yet so in triclinic only inversion is possible. In the case of monoclinic, a two-fold along the B axis and a mirror perpendicular to the B axis. Now, orthorhombic, three perpendicular mirrors and all the three axes can act as a rotation axis, that is only two-fold rotation. When you go to tetragonal, the three axes are mutually perpendicular and the C axis being unique, it acts as a four-fold axis. In trigonal, the three-fold is operating along the body diagonal passing through the origin. In the case of hexagonal system, the C axis which is the symmetry axis or unique axis, acts as a six-fold axis. In the case of cubic, though the three axes are equal and mutually perpendicular, there is a three-fold axis operating along the body diagonals. So now it is easy to recollect the A, B, C, alpha, beta, gamma and the equality in the dimensions and the angles alpha, beta, gamma that are equal and 90 degrees.